My dear students, we have already learned about electron affinity. That's very important periodic property of chemical elements. So, is there any option to find the value of electron affinity? The question is very significant because still the value of electron affinity of many elements are unknown. In periodic table, lanthanides, actinides, many transition metal elements, p-block elements, their exact electron affinities are still unknown, and many values are still there are many corrections are also. So, is there any methods? Indeed, there are methods. There are two methods that is using theoretical and mathematical concept, and two others are using experimental methods. Let's discuss on it, and I'm going to very briefly discuss on this matter, and we will discuss and we will elaborate about these methods later. The first and foremost one is Born-Haber cycle. As you all aware about Born-Haber cycle, which is a very famous classical approach for the determination of lattice energy of ionic compound. Lattice energy is nothing but the amount of energy required to break an ionic compound in solid state into gaseous ions. Or in other words, the amount of energy released when two ions at its gaseous phase combine to form an ionic solid. So, it is a classical method of applying Hess's law. Born-Haber cycle is using Hess's law for determination of the compound lattice energy. What is Hess's law? The energy required for the formation of a compound in a single step is equal to the total amount of energy required for the formation of the same compound in multiple steps. Both are same, right? So, Hess's law and Born-Haber cycle is used for the determination of electron affinity of an element. Okay, that's the first classical approach, which is purely mathematical method. The second one is Hartree Fock method, which is more precise than Born-Haber cycle. Hartree Fock method is using quantum mechanical concept and applying computational technology, computational methods for the determination of electron affinity of element. This is purely depends on a time-independent Schrodinger wave equation for the calculation of wave function of an element. From that, they are determining the electron affinity of element, which is also mathematical calculation and very accurate value. We will obtain very accurate value, but it's insufficient for the determination of many corresponding elements, especially lanthanides and actinides. The last two are experimental methods. The laser method. I'm going to explain on it, laser method. This laser method for the determination of electron affinity was published in Nature Communication in 2022 by Swedish scientist Mova and Gustav. Both are young scientists. They have discovered a method, a laser method. In that method, they are using nothing. In a sample which contain anions, the negative ions. A sample, this is a sample box, which is contain anions. Okay. This sample is contain many negative ions. Okay, anions. Anions are contained in a sample box. So this is irradiated with the H nu, a photoelectron. A photon. A photon is bombarded on a sample which contains negative ions. They are continuously varying lambda or nu or energy. Any of the factor. They are continuously varying the wavelength of the beam. That is the source beam. At a particular point, that is called threshold point. At a particular point, electron get ejected from the negative ions. That is, electrons get ejected from the anion. That is the beam which is striking the sample which contain negative ions at a particular point, that is called threshold point. And that point, electrons get ejected from the negative ions. That wavelength, that particular wavelength is recorded and the corresponding energy is calculated. That energy is equal to electron affinity. That's a very recent method for the determination of electron affinity of element. That's very important. And the laser beam which is used for the determination for bombarding the sample is titanium and sapphire. Titanium sapphire laser beam is using. This is one of the important methods. The last and the fourth method used for the determination of electron affinity value is electron capture mass spectrometry. Mass spectrometry is one of the very familiar method for the chemical analysis. What's the basic principle of mass spectrometry? Formation of an ion and analysis of that ion with respect to mass to charge ratio, M bar E or M bar Z. Mass to charge ratio and spectra is recorded, right? The formation of an ion is very important part in mass spectrometry. In this case, in almost all cases, in mass spectrometry, positive ions are forming. Positive ions. That means ionization of an element or an atom at its gaseous phase into a positive ions. So, mass spectrometry is widely using ionization energy, right? But in the case of electron capture mass spectrometry, what is the charge? Negative ions or anions. Anions are forming. Instead of forming positive ions, anions are forming. These anions are recorded, these anions are detected and arranged with respect to mass to charge ratio, and spectra is recorded, finding out the element. Right? So in electron capture method, the electrons are captured, electrons are added onto the atom at its gaseous phase. So anions are forming. These anions are recorded with the support of electron capture detector ECD, and this ECD detector is used for the determination of the element, and spectra is recorded in accordance with the M bar E, mass to charge ratio. From that spectra, we can find out the amount of energy required to attach an electron into a gaseous atom. That energy corresponds to electron affinity. Okay. So, electron capture mass spectrometry is widely used for determination of contaminants in pest, contaminants in pollutants, contaminants in food, other foods, and in environmental chemistry, radiotherapy, as well as isomer determination. In organic chemistry, many isomer determination where they are using electron capture mass spectrometry. Okay.